Go ahead, you may need to write something down, although I promise you'll have most of these memorized after a unit of all this. We need the exact tangent of 60 degrees. I'm hearing people say root 3, and if you're saying root 3, you are exactly right. Now, let's review that real quick. Tan 60.
I threw my picture.
So our picture looks like this. Here's our 60-degree angle in standard position. Kids, we're going to move out of quadrant 1, and so it's really important you're in standard position. That means start here, right? That's a 60-degree angle. Since I dropped a perpendicular and created a 90, that makes this a 30, 60, 90 triangle. The sides of a 30, 60, 90 triangle are in the ratio 1 to root 3. So somehow you have to remember that the short leg is 1, the long leg is root 3, and the hypotenuse is 2. That's left over from your time with Mrs. Hastings Smith, or whoever you had for geometry. Then you got to remember that tangent, TOA, is opposite over adjacent. So in our triangle, this is the angle right here at the origin. That's the angle we always want to look at. The opposite side is over here, and the adjacent side is here because that's the hypotenuse. So root 3 over 1. So those of you that said root 3, righto. Perfect. Okay? All right, so that's kind of a quick recap of some of the basics we talked about yesterday. All right, let's find where we are now. 4.3, coterminal angles. Anybody have any idea what we mean by coterminal angles? Well, when we draw an angle, we start here, positive x-axis, that's standard position. This is called the initial side. This is where I start. This would be called the terminal side because that's where I end when I draw my angle. Coterminal angles are angles that start and stop in the same place. In other words, they share the same terminal side. So let me I'll just call this 60. Can you think of another angle that terminates on that ray? Get creative, there's lots of them. What? 30? No, 30 would terminate right here, so no.
Negative 30?
Negative 30, now you're starting to think along the right lines, but negative 30 would look like this. It does not terminate on the same place. Negative 300, Lewis says. Think about that for a second. Wouldn't negative 300 stop at the same place that 60 stops? Yeah. So a coterminal angle for 60, one possibility is negative 300 degrees. That is absolutely coterminal. Can you think of another one? There are infinitely many.
Negative 660.
Negative 660. Now let's talk about that. What does that even look like? Negative 660. Well, wouldn't it have to go all the way around? And then another 300? Wouldn't that terminate in the same spot? It sure would. Are you starting to get the idea of why there are lots of them? What's the difference between Lewis's angle and Oliver's angle? A revolution. Oliver just added an extra revolution. Could he have added 2 revolutions? Yeah. Now, they did it negative. How about 420? Would positive 420 be coterminal? Yeah, because that's just a revolution and 60 more. To find coterminal angles, you take your original angle, whatever it is, I'll call it theta, and you either add or subtract, if you're in degrees, you add or subtract revolutions, which are 360s in degrees. So we say, all right, let's let n be some whole number. Take whatever your original angle is. For me, it was 60. I'm gonna add one 360 or subtract two 360s. That is your general form for all coterminal angles in degrees. Now, what if I'm in radians? What will change? Well, what's a revolution in radians? 180 is half a revolution, and 180 is pi radians. So what's a full revolution? 2 pi. 2 pi. Yeah. So if you are in radians, you're not gonna add and subtract 360, obviously. You're gonna add and subtract 2 pi. 2 pi is a revolution. To find coterminal angles, you add or subtract revolutions.
What does the n, is that like new?
No, n is a whole number.
Oh, okay.
So it's like adding 1 2 pi, 2 pi times 1, 2 pi times 2, 2 pi times 3,
Okay.
right?
How do you find n?
Huh?
How do you find n? Or is n is just the number of times it's going
And
around?
it's just the number of times it goes around. It could be anything, whatever, however many times you want to go around, right? Okay, so now we're going to find a positive and a negative coterminal angle for 30 degrees. How do we find coterminal angles? We add or subtract revolutions. So start with 30. What's a positive coterminal angle?
390.
390. What's a negative coterminal angle?
Negative 330.
Negative 330. Easy. How about if we start with negative 150, if that's our starting angle? What would be a positive coterminal angle for negative 150? 210? How do we find coterminal angles? We add or subtract revolutions. So take your negative 150 and add 360. What's a negative coterminal angle for negative 150?
Negative 510.
Negative 510. Add or subtract revolutions. How about 2 pi over 3?
Add 2 pi.
2 pi over 3 is our starting angle. So we either add a revolution or we subtract a revolution, right, to get a positive and a negative. So let's get ourselves a common denominator. So this is 2 pi over 3 plus 6 pi over 3. So my positive coterminal angle is 8 pi over 3. What's my negative? Negative 4 pi over 3. Don't make it hard, kids. It's simple. You're adding 2 pi or subtracting 2 pi. Now, you do have to be careful in one situation, because I kind of just led you to believe that to get positives, you add a revolution, to get negatives, you subtract a revolution. Think about this for a second. What if the angle I started with was 13 pi over 5? If I wanted a negative coterminal angle, I would subtract 2 pi. But what happens when I subtract 2 pi?
You're left with
It's
-3
still
pi.
positive. So I am gonna have to subtract another 2 pi.
So is that when you do the n?
Well, I I never do the end, this is how I write all my answers, but yes, I would have to let n go on twice, I have to go on twice to finally get a negative answer. If the angle is bigger, then it's gonna take me more revolutions to get it down there where I need it to be. Okay? Alright, perfect. Definition, trigonometric functions at any angle. Now, I know what you are thinking. You're thinking, Mrs. Ford, we already did this. I already have the definitions. You already told me, or Mrs. Hastings Smith told me, or someone told me, that the definition of sine theta is opposite over hypotenuse. Right? That, you have that definition already, SOHCAHTOA. Here's the deal, folks. If you're gonna use that definition, then what has to be the case about your triangle?
Has to be right.
Has to be a right triangle. Now, I don't think it happens in this chapter, but definitely in chapter 5, we're gonna have triangles that look like that. And you're not gonna be doing SOHCAHTOA with that. Furthermore, there are situations where we need trigonometry, where it's not even possible to draw a triangle. So, for example, you know how that first question I gave you today, or one of them was, I said find the tangent of 60? You drew 60, you made a nice little triangle, it was perfect. What if I said find the tangent of 90? Think about that for a second. Or the tangent of 0. You can't make a triangle. You can't drop a perpendicular to the x-axis to create one of our triangles like this. That's not possible. So we need some alternative definition for sine, cosine, and tangent. I use this all the time. There's nothing wrong with it. But we're gonna expand it a little bit. If this is theta, we said this was opposite, this was adjacent, and this was hypotenuse. Right? Every time. I'm gonna draw a big circle around here containing that point. And then, instead of calling this the hypotenuse, what can I call it in terms of that circle there? The hypotenuse is the radius. And this point that's on the circle would have what coordinates? Now think about it, here's the origin. You're coming over and up. Well, I don't have any numbers in the problem, but isn't this x and y? So this adjacent side is x, and the opposite side is y. So an alternative, what we call the circular definition for the sine, instead of hypotenuse over opposite, we'll say y over r. And could we do the same thing for all of them? Take the SOHCAHTOA definition and rewrite it? Absolutely, so that's all done for you right here. Now, you'll notice for everything but sine and cosine, they have a little qualifier there next to the definition. Because why?
That can't be 0.
These are all fractions. Sine, cosine, tangent, secant, they're all fractions. And what do we know about fractions? The denominator can never be 0. Now, is it possible to have points where x or y or both are 0? Is that possible? Yes. And because of that, you're going to run into problems in your definitions because you can have 0 in the bottom. When we start graphing these things, they're gonna be full of asymptotes because there are undefined values, but not the sine and cosine. The sine and cosine are perfect because the sine and cosine have what as their denominator? The radius. X can be 0. Y can be 0. Can R be 0? No. So sine and cosine are never undefined. Remember your BFFs? What'd they look like? Did they have any breaks in them? No, because they're never undefined. Everything else we graph is gonna be broken up into chunks because it's gonna have these asymptotes. Anyhow, those are called the circular definitions, you gotta know them. Now, it really isn't a big deal because you've already memorized SOHCAHTOA, so you just have to kind of relate this picture to SOHCAHTOA and you won't have any problem with your circular definitions. Okay? All right. Here we go. We're gonna find all 6 trig functions for 315 degrees. So we're gonna find the sine of 315, we're gonna find the cosine, we're gonna find the tangent, we're gonna find the secant, cosecant, and cotangent. Okay, here we go. Any thought on what we might do first? Oh, you guys know me better than that. We draw a picture. We always draw a picture. Draw a picture. What does 315 degrees look like? Well, remember, when you start here, and you go that way, where am I gonna put 315 degrees? All the way around to here, right? There's my angle right there. This is 315 degrees, all the way around here in quadrant 4. Now I'm gonna drop my perpendicular because it's possible to do that. Note that your perpendicular always goes to the x-axis. So when you build your triangle, it's always going to be part of what we call the butterfly bow tie. It's always going to be one of these, because your perpendicular always goes to the x-axis. This is the angle we need. Always we need the angle at the origin, inside the triangle. Inside the triangle, at the origin, can you figure out how big that angle is?
It's 45.
45?
Yeah. 'Cause
You okay with that? It's gotta be 45. How do we know that?
45 plus 315 is
Because all the way
360.
around is 360. If we went 315 and that leaves 45 left to go, this is called the reference angle. And once I figure out what my reference angle is, remember the angle I'm doing is 315. But in order to get 315, I do a reference triangle. And I know the sides are 1, 1, root 2. But be careful, because I am in quadrant 4, something is going to be negative.
The Y.
The y is going to be negative, which is this one right here, right? If you're not in quadrant 1, something's negative. So you got to keep track of that because that's going to impact your answers over here. What's the sine of this angle? Remember, it's y over r, or opposite over hypotenuse. So the sine is going to be
-1 over I.
-1 over root 2. Shoot, I forgot to ask him about that. So that's negative root 2 over 2. I'm going to make myself a note. Yep. So today we'll rationalize, but I'll see if he's going to make his kids do it. Now, if the sine is negative 1 over root 2, then the cosecant is negative root 2 over 1. Alright, what's my cosine? Cosine is x over r, or adjacent over hypotenuse. So cosine is positive 1 over root 2, which means the secant is positive root 2. Are you following along, guys? Are we making this
If you,
managing? Okay. What's tangent? Tangent is y over x, or opposite over adjacent, so that would be negative 1. And then obviously its reciprocal will also be negative 1. Want you to notice something? How many of that, there's 6 there. How many of those 6 did the negative impact? 4 of them? You don't want to forget that negative, right? You're kind of doomed. Don't forget your negative. Every time you draw a picture, if you are not in quadrant 1, stop yourself, put in your negatives. Okay, does someone have a hand up? Oliver?
if you take, it seemed like we were taking all of these things at 45 degrees, not at 315.
We're doing what?
It kind of feels like we're doing it at 45 degrees. Does it count for 315 as well?
It does, as long as you didn't put the negatives in. So the basic ratio numbers are coming from the 45, 45, 90 triangle, but the answers have taken into account that that triangle is sitting in quadrant 4.
Okay.
So the functions for the reference angle are the same as for the original angle, as long as you take into account the negatives. Same is true of coterminal. I did 315. What if I'd done negative 45? Wouldn't that be exactly the same picture? Yep, with exactly the same numbers. So the functions of the original angle will match the functions of all the coterminals. Okay? They will match the reference angle, except some of them are negative. You gotta pay attention to that. Okay. I'm gonna change number 3, and we're gonna do negative 2 pi over 3. So we're gonna find, we're gonna find the sine and all this stuff for negative 2 pi over 3. Alright, anybody have any idea how many degrees negative 2 pi over 3 radians is?
Negative 120,
How did you know that?
because 2 pi is 360 divided by 3, and negative is negative 120.
Okay, so we talked about earlier, pi is 180, so 2 pi is 360. This is a third of 2 pi, so it's gonna be a third of 360, so it's gonna be 120 degrees negative. So let's draw negative 120 degrees. Negative 120. Would you agree it looks like this? So there's my angle, that's negative 120 degrees. Let me make my perpendicular to the x-axis. This is called my reference triangle. Now I need my reference angle at the origin. So you have to figure out what that is, which you can do. How big is it? 60. Make sure that digests. 60. Which means this is root 3, this is 1, this is 2. Those are the ratios in a 30, 60, 90 triangle. Or if you want to do it in radians, pi over 6, pi over 3, pi over 2 triangle. Stop. I'm in quadrant 3. Something has to be negative. What's negative?
1 and
X
negative.
and Y are both negative. X and Y can and will be negative. R will never be negative. R is always the radius of the circle, it's R. But X and Y, because of the quadrant system, can be negative. All right, so here we go. What's the sign? Negative root 3 over 2, which means the cosecant is negative 2 over root 3. Or if we have to rationalize, negative 2 root 3 over 3. What's the cosine? Negative 1/2, which means the secant is negative 2. What's the tangent?
Root 3.
Root 3. Positive, because X and Y are both negative. Opposite and adjacent are both negative, so that's root 3, which means your cotangent is 1 over root 3, or root 3 over 3. All right, when you get back, we're gonna do some, we'll go quadrantal angles. We got your sheet at 49, folks. 49. Back in your seat.